Let's now start coding this project. 2 minus long 1, and yeah, the rest of it is fine. Radius, we have kept radius as 67,100 kilometers, and then you calculate all of these things and you get the Habermas distance. So here what we have done is get Habermas distance. Okay, so this is the entire data that we have. Now let's see how the map looks. Yeah, so this is how the map is starting to build up. This is the place that we were building the map for. So we have obtained such a structure over here. Okay, so let's now start coding this project. Okay, so the very first thing that we'll have to do is to create a graph that would connect all these points and would create a map out for us. So for that, we can create a JSON file here itself where we will be storing all this data. And yeah, each point will be an object. So this will be the point object that consists of latitude, longitude, and their array of neighbors. So first of all, so we'll create an array of these objects, and also we'll assign an ID to this point because we will also be traversing this graph. So when we traverse this graph, we can just, when we are setting the visited flag of any point to true, we can use this ID at that point. That would be more convenient. So yeah, so first of all, the first and foremost thing is that let's try with 1 or 2 points. If that works, everything will be working fine. Okay, so first of all, let's create a JSON file that consists of all the points dot JSON. Okay, no, let's not do this. Let's create a new folder, data, and in this I'll have points.js. In points.js we will have an array of points. So first of all, let's have this as points equals an array and export for points. Fine. So this has module dot export equals points. Okay, so this is it. Mm, For points, let's first take this to be the origin. Also, I will have to set the origin. So origin will, okay, for, let's set that up here itself. Origin.js export const origin equals all latitude would be 28.654124, and the longitude would be this point. Okay, so this is our origin, and I'll just export this. Okay, so now this is done. We have the origin. We can access this origin from anywhere. Now, let's try something in the front end. Let's try a basic. Uh, let's try connecting just two or 3 points, and then let's see if that works. So we don't need anything here. We just need a canvas. Or ref, we'll give it a reference as canvas ref, and the height would be window dot inner height, and width would be window dot inner width. So this is the canvas that we are using. Import use ref. Okay, so just remove all of this. Import use ref from React. Okay, let's also use this reference as canvas ref equals use ref, and yep, that's it. Now let's take any 2 points. So first of all, let's write this formula overall. What we will be having is the origin, and along with the origin, we also have the point that we want to plot onto this. And what it will be returning us is the x and y. Okay, so let's create that function. For the function, okay, so in the source itself, I'll create a utils, and let's create a function over here called as mm, get xy dot js. Okay. So first here we will be importing a module called as origin. So we have the origin here, and also let's export default. Okay, so let's create a function get xy, and then just export it. Fine. So for get xy, we need two. We need we need a latitude and a longitude. For origin, we do have the latitude and longitude, and okay, let's not keep it as latitude, longitude. Let's keep it as point. From here, we will be passing the point over here. Once we pass the point, we can now get everything out of it. So the first thing that we will be doing is converting everything into radians. Okay. Okay, so to convert anything to radians, we use these formulas. We'll be multiplying it with pi and then dividing by 180 degree, because 180 degrees is equal to pi radians. So yeah, so for that, let's do one thing. Let's have all of this in this format. Let one on let one equals origin dot latitude on slat 2 equals origin dot longitude on long 1 equals origin dot longitude. This will be point, and also long 1, and you have a long 2 point dot longitude. Okay, so we have the latitude and longitude converting it into radians now. So to convert it into radians, we just what we are doing here is multiplying by pi, multiply by math dot pi, divide by 180. So this is how it is going to be. Let's do that with everyone. Okay, so you have all the lat and longitude. Now apply the formula to get the Haversine distance. This is the formula, and we also need to know what is the radius. Radius is 6371 kilometers. I'll write it in meters. I'll just okay, so this is going to be lat 1, lat 2 minus lat 1. This is going to be long 2 minus long 1. And yeah, the rest of it is fine. Radius, we have kept radius as 6371000 meters. And then you calculate all of these things and you get the Haversine distance. So here what we have done is get Haversine distance. Okay, so there is some problem over here. Okay, so first, let's do one thing. Let's create a function called _sign distance where we input lat1 long1 lat2 long2, and let's write this up here. Mm, okay, so first we'll have to get the x distance. That would be it would be something of the sort that y is not moving, only x is moving. So for that we will write the function average and distance where, okay, so I also, okay, so we have messed up a little bit. Mm, okay, so first we have converted this into radians. Let's not do that here because it's already converted into radians. Once it's converted into radians, we calculate the x distance, which is average line distance between lat1, which is the origin. Then you have origin comma, so for x you will be using lat1 comma lat2 because this is the reference. Then you lat1 comma long1 because this is the reference. Along with that, we will also be using the distance of x, but long one will be same. Long two would be long one. Long two is not needed because we are calculating only the x distance. And also for the y distance, we will call the function lat1 long one and lat1 long two. Yeah. So we get this. So basically for x distance, we are not changing the y, and for y distance, we are not changing the x. Now we get the x and y distance. Let's see what is our next step. Once we get the x and y distance, we also need to know the max distance. So the max distance that we will be keeping here is would be, let's say, it won't be too much. It would be 5,000 meters. That is 5 kilometers, or let's say 6,000 meters. That is 6 kilometers. And once you have the max distance, now you just have to normalize this. We also will be sending the canvas width and height over here. So, okay, so that will be done. Let's send the canvas width and canvas height. Once we get this, we can now calculate x and y. So const x equals uh, x distance upon max distance into canvas width. Similarly, const y equals y distance upon max distance into canvas height. That is it. Will return x and y. Fine. So this is how we are going to get the normalized x and y. Here we'll first write a test function that tests if it works. Once it starts working, that would be great for us. So, mm, okay, so canvas width and height. Let's now uh, create, okay, so let's create a use effect. So, under the use effect, so we will uh, we will have a point. We will have to take some point. So the origin is set, right? Origin. Let's see where the origin is. Yeah, so the origin is set. Now I just need a point that will suffice that. For that, I'll take some point. Let's say this point. And okay, so this is the point that I'm going to take. Fine, so this is that point. I'll first get the x and y as get xy, get xy, and pass these 2 points, which is the latitude and longitude. Now import get xy from slash c slash utils slash get xy. So have I exported it here? Yeah, it's exported. Uh, we get the x and y. Once we get x and y, we have to draw a line from that point to this point. So for that, for first, I'll draw line from 0 comma 0 from some point to this point. Okay, so for that we will have to take the origin as well. So we will be having a function where we will be taking the initial point, which would be 0 comma 0, and x comma y, and I'll just declare the function implementation over here, which takes the x dot y dot x end and y end. So if I draw the line, for drawing the line, we will be using the Canvas API. So for that, we need the canvas, that would be canvas ref dot current dot get context 2D. So we have the canvas, we have the context over here. Once we have the context, we can simply draw a line. So how to draw a line? Drawing line using canvas. Okay, so we have to draw a line. We will move to 0 comma 0, then we draw a line to and then stroke it. So yeah, so first we'll just say context dot begin path. And then we have context dot move to x start comma y start. Once we move there, we can simply line to uh, move to line to x and comma y and it should be a stroke line. So yeah, this should do. Let's try running the application. Mm, okay, and yeah, start. Module has no exports. Okay, I just start this up in Chrome first. Okay, so let's change this export default get xy. If we can do that, which falls outside of the project source directory, related to the source are not supported. So, okay, so we'll have to transfer this over here. Yes. Now, if I look at this, so I've changed the import but not saved it. Now it's done. Unable to see anything over here. So we have the canvas. Okay, so there has to be some problem. Are we not sending the canvas width and height here? Yes, we are not sending the canvas width, which is window dot inner width and window dot inner height. Let's just keep it here canvas width equals window dot inner width and font canvas height equals window dot inner height. So let's just move it out of here. We will change these to canvas width and this is the height. Yes, so that works. We can see lines over here, but why are there two lines? Okay, so now we have only one line and that works fine. Maybe the distance that we are getting is wrong because the value that I had seen here was a bit too much. Console.log as distance, y distance. If you just try this, so it's a huge value because if you convert it into kilometers as well, it will be a very huge value. Uh, lat 1, lat 2, all of these things are fine. Let's check if we are doing well with the formula. Yeah, now this looks fine. If you convert it into meters, it will be 2 kilometers and stuff. So yeah, that looks fine, but what did we do? Okay, so maybe the sign thing was not working. I just added brackets here and yeah, it's working better now. So yeah, let's keep it that way. Just commenting this out. Fine. Now that looks fine. Oh, okay, so they will also have the function draw line. I want to set something for this line. Okay, so we have ptx dot line width as 10. Okay, so let's do that. Let's Okay, so I do have the data for 21 points currently. I'll add data later on now. But first of all, let's see how can we map these points and how can we create a map out of it that would be visualizable. So for that, what we'll be doing is we'll go to app.js and we'll have to call this drawLine function as we traverse throughout this graph. So if you just look at this data, the points data, it has been created like a graph. So this is the adjacency matrix, you can say. So if you have an index 0, you have neighbors as the index 1. Also for index 1, you have neighbors as 0 and 2. So this point is connected to this and this is connected to index 2, then to the index 3 and so on, whatever. And for some of them, if there's a crossroad there, it is connected to 3 points. If it's not a crossroad, it's a straight road, then it is connected to a single point or whatever, anything of that sort. However the roads are being constructed and however is the structure. So this is how basically we have the entire graph created. Now what we have to do is we have to perform a graph traversal, and while traversing we also have to draw this onto our canvas so that it is visualizable. So let's start doing this, and I guess this is the origin maybe. Yeah, so the first point is the origin, and we are starting from the origin all the way through. So let's start here. Let's see what we can do. So uh, whenever the component mounts, that is whenever the page loads, we will create map. Now let's create a function called as create map. And within this function, what we'll do is we also will be having uh, import named as points, and now we will have to use these points here. So okay, so for that, first of all, let's do one thing. So now we are traversing the graph. We can do that by BFS or DFS, anything that you want. We will do it using BFS. Let's start implementing this function. So first of all, we will have a queue. As we know, the standard breadth search function. So we have a queue first of all. Okay, so we don't need to declare a queue here. We'll just declare the visited map. Once we have this visited map, we will traverse over all the point in points for a const point of points. Once we traverse over these points for every point, if not visited of point, we will simply uh, we will simply call the BFS function that consists of the points array as a whole visited. Okay, so this is what we need, and let's change the BFS function. In the BFS function, we will be having the points and visited. Now declare a queue over here. In this queue, just put the first point that we want to. Now, while queue is not empty, we will first let's take let's pop this out of the queue. So mm, const temp equals queue dot pop. Once you pop, okay, so q dot front, let's say, and then you will have to q dot shift. Once this is done, we will now, so the temp is popped out. Now for const neighbor of temp dot neighbor, what we can do is we will have to push the neighbor into the queue. Along with that, mark the neighbors visited as true. Also, and this is true. Also, draw a line from temp dot latitude to temp dot longitude. From temp dot latitude comma longitude to neighbor dot latitude comma neighbor dot longitude. So this is how it should work. Okay, so we don't need points here. So okay, so const neighbor of temp dot neighbors. If we have a neighbor, then visited of neighbor equals true, and here we are putting out visited of point as true. Okay, so okay, so let's do one thing. We in points we have an index of points that acts as a unique identifier. So let's take advantage of that. If not of visited of point dot index, then BFS points visited. Fine. Once the point arrives here, const q dot push point, and we are pushing the point in it. Once we push the point, get the front, then shift the queue const neighbor of temp dot neighbors. Okay, so temp is the first element of this queue. Let's make some more changes here. Let's not put q dot push point. Let's put the index of point. Once we put the index, q dot shift for const neighbor of mm, points of temp dot neighbors. This is what would be needed. So points is globally declared as well, so never mind, points won't create a problem. So for const neighbor of points of temp dot neighbors, q dot push neighbor. So yeah, that is okay. So this will be an integer. Visited of that integer would be true, and then you draw the line, and that goes on. Now let's get the next point. The next point would also be an integer. That integer and you find the index of it and so on. So yeah, so that should do. The map should be created. Uh, okay, so let's see if this works. Okay, so we also have the getXY function by which we'll get the x and y distance, and then we will pass the x start, y start, x end, and y end. Okay, so once we get this, we will get the x start. Let's say let const of x start equals points of temp dot latitude comma points dot temp points of temp dot longitude. Get xy for this. Get xy x start comma y start. Get xy, and similarly for drawing before drawing the line, get x n and y end. Get xy points of uh, visited of neighbor 2 points of neighbor dot latitude and points of neighbor dot longitude. So that should work. And also edit this x start x x start y start x and y and so that should do for us. Let's see. So q dot empty is not a function. Okay, so while not of q dot while q dot length is greater than 0, let's do this. Still there's a problem here. Okay, so this is going to be q dot shift. Okay, so the code is entering this loop, but here there is some problem, yeah, because the getXY function is wrong. So let's change it. Points of temp, points of neighbor, comma, canvas width and canvas height. Fine. This should work now. And maybe we have not added this condition over here. If not visited of neighbor, only then perform this. Okay, so this is working actually. Yeah, this is working fine, but I'm not able to see anything on the screen. Okay, so we are basically not getting into the draw line function, which means that when you go to get xy, there is something that is creating a problem. And when we go to get xy, do we get the x and no. So let's do something. Start coordinates, and let's keep this as the end coordinates. Fine. So we get this. Let's take start coordinates dot x comma end coordinates dot y with okay start coordinates dot y and end coordinates dot x comma end coordinates dot y. Yes, so that should do it. So I think the problem is that we are also passing points which is not required. So yeah, that is good, but so the thing that I've done here is that I've written some code here. So what it does it will generate points for us so that these points can be put into the array of points. I have actually done some I've actually computed some of these points and added here, but so what basically this script does is so for routes to find you have the starting latitude longitude and the ending latitude longitude. From that, I am hitting onto the TomTom API for routing so that I get all the points. And these points, then we will be mapping onto our user interface. So basically, this is a huge data that we already need to have, but I am just scraping this data out of this TomTom API so that we can use it for our interface. So let's just run this. Okay, so I have sent it to output.json. In output.json, we get the entire data. I'll just copy and paste it to the points array. Okay, so this is the entire data that we have. Now let's see uh, how the map looks. Yeah. So this is how the map is starting to build up. This is the place that we were building the map for. So we have obtained such a structure over here. And now the next feature that we want to add is the panning and zooming thing. So